Dear students, today in this session we are going to discuss about Newton's third law, and in the last classes, if you see my classes, we discussed about Newton's first law, Newton's second law, and momentum also we discussed, right? So in this session we will try to understand Newton's third law. Along with Newton's third law, we will try to understand conservation of momentum. Conservation of momentum. Let's see. See here, Newton's third law. Newton's third law. So if you remember the last classes, can you tell me what is Newton's third law? Newton's first law is qualitative analysis. Newton's second law is quantitative analysis. Newton's third law is about isolated forces. About isolated force. According to Newton's third law, there is no single force will exist. There is no single force. According to Newton's third law, there is no single force, which means for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction called Newton's third law. Just I will write, try to understand. According to Newton's third law, for every action there is an equal and opposite reaction. Opposite reaction. For every action there is an equal and opposite reaction, which means, for example, here sun is there and here it is earth is here. Correct? We know sun attracts earth. Sun attracts earth. So when sun attracts earth, at the same time earth also attracts sun. Earth also attracts sun. Every reaction there is an equal and opposite reaction. For example, if I am walking, I cannot able to show down, right? Try to understand. If I am walking, so how it is possible? I am applying some force on floor. That is action. Due to that, I am moving forward. It is reaction. For every reaction, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. Right? So here we will write there. We will write here. Two bodies are there. Here one and it is two. Force acting on one due to two. This one already we discussed, right? Force acting on one due to two is equal to equal and opposite. So minus force acting on 2 due to 1. Clear? Force acting on 1 due to 2 is equal and opposite to force acting on 2 due to 1. Magnitude wise both are same. But they are opposite with each other. That is called Newton's third law. Small definition this, right? I hope you understood, right? Clear? But we are thinking it is small. But further classes, further topics, this one only plays a major role. So I hope try to understand Newton's third law. So we will go with the conservation of momentum. Clear? Now see this one. What is this one? Conservation of momentum. Try to understand. In Newton's second law, we already derived one expression. F is equal to delta P by delta T. Right? I will write this one. F is equal to delta P by delta T. That means for this, we already see one example. A car is there and it is moving some velocity u. Some force is applied. Some external force is applied. I will write this is external force. External force is applied. Due to this external force, the speed will change. Due to the change in speed, momentum also changes. Right? This is what we discussed in Newton's second law. Correct? That means here when there is some external force acting on the body, then automatically there will be some change in the momentum. Change in momentum. So here I will write here F external can be written as delta P by delta T if very very important, if then only, if F external is equal to 0, then what will happen? What will happen? That implies delta P by delta T is equal to 0. Delta P by delta T is equal to 0, which means delta P is equal to 0. Why? Because it is in denominator. Delta T is in denominator. It will go this side. So multiply with 0, it becomes 0. Delta P is equal to 0. Delta P is equal to 0. So here delta P is equal to 0, which means what is delta P? Delta P is change in momentum. What is delta P? Change in momentum. Change in momentum is final momentum minus initial momentum will be 0 here. So here it is initial momentum minus is there. If you go that side, it will be plus. So here it is PF which is equal to PI. PF is equal to PI. This is law of conservation of momentum. Law of conservation of momentum. What is law of conservation of momentum? If there is no external force acting on the body, the momentum will be conserved. Momentum will be conserved, which means initial momentum is equal to final momentum. Initial momentum is equal to final momentum. That's what we got here. I put F external is equal to 0. When F external is equal to 0, what we got here? Final momentum is equal to initial momentum. So we have to keep in our mind, very very important formula. If there is no external force acting on the body, momentum is conserved, which means initial momentum is equal to final momentum. Very very important, make a note. So we will write here, according to the law of conservation of momentum, if there is no external force acting on the body, if there is no external force acting on the body, initial momentum is equal to final momentum. This one is called conservation of momentum. If F is equal to 0, if there is no external force acting on the body, momentum is conserved, which means initial momentum is equal to final momentum. That is, here I will write if F external is equal to 0, delta P by delta T is equal to 0. That implies delta P is equal to 0. What is delta P? PF minus PI is equal to 0. So here PF is equal to PI, or PF is equal to PI, or PI is equal to PF. Initial momentum and final momentum should remain same. This is what? Conservation of momentum. I hope you are understanding, right? Conservation of momentum. Again, I already told you this conservation of momentum is also known as conservation of linear momentum. Why? Because we are discussing about the linear motion only. So here, what are the momentum is there? This momentum is called a linear momentum. This one is also known as conservation of linear momentum. Clear? Make a note.